Namaste everybody. Hope all of you are doing well. Okay. So today we are going to talk about the expression of final temperature in case of adiabatic irreversible expansion. Okay. Before moving ahead, let us become clear about few of the key terms over here. Okay. When I say adiabatic condition, adiabatic means what? The Q will be equal to 0. Okay, and when we talk about irreversible work, okay, so in this case the irreversible work in case of adiabatic condition will be what? Minus P external into delta V. Okay, I hope these things are very clear to you, and now we'll move to find out the expression. Okay, let us write it down. Final temperature for adiabatic irreversible expansion. Okay, now all of us are aware about the first law of thermodynamics. What does it say? It says that delta U is equal to Q plus W. Okay, where delta U is what? Change in internal energy, Q is our heat, and W is our work. Okay, so from first law of thermodynamics, from first law of thermodynamics, what does it say? Delta U is equal to Q plus W. Okay, where delta U is our change in internal energy, Q is our heat, and W is our work. Okay, and we have already said that in case of adiabatic condition, Q will be equal to 0. So in this case, delta U will be equal to what? Delta U will be equal to W. Okay, and we know that delta U is equal to what? NCV delta T or NCV dt, where N is number of moles, Cv is what? Heat capacity at constant volume, and dt is change in temperature, and when we say delta T, it becomes change in temperature. Okay, and W is what? Minus P external into delta V. Minus P external is what? Our external pressure, and delta V is our change in volume. Let us write it down. So delta U is equal to what? NCV dt, and if we take 1 mole, it becomes what? Cv dt is equal to what? Minus P external into delta V. Okay, where Cv is what? Our heat capacity at constant volume. Okay, dt is our change in temperature, P external is what? External pressure, and delta V is change in volume. Okay, now this Cv dt can be also written as Cv delta T and minus P external into delta V. Okay, let us expand it. So Cv delta T becomes what? T2 minus T1, where T2 is our final temperature and T1 is our initial temperature, and here it will become what? Minus P external V2 minus V1. Okay, now remember the case of ideal gas. What does it say? PV is equal to nRT, where P is pressure, V is volume, N is number of moles, R is our gas constant, and T is temperature. So from that equation, V equal to what? nRT by P. We are going to use that. Okay, so here it becomes what? Cv into T2 minus T1 is equal to what? Minus P external, and V2 can be written as what? nR T1 by what? Sorry, nR T2 because it is V2. So nR T2 by P2 minus nR T1 by P1. Correct? Okay, so here you can pause and note it down. Okay, so let me remove the first few equations. Okay, just rewriting it. Okay, this becomes what? Cb into T2 minus T1 is equal to what? Now, if we take n is equal to 1, because we have been considering what? 1 mole. So, n will be equal to 1. So, this becomes what? Minus P external R T2 by P2. Okay, minus R T1 upon P1. Correct? Now, let us just expand it. This becomes what? Cb into T2 minus Cb into T1, correct, is equal to what? Minus P external upon P2 into RT2, right? Into minus minus plus P external RT1 upon P1. Okay, hope this much is clear. Now what we are going to do is we will take the terms of T2 on one side and T1 on other side. So what we will basically doing, we will move this term to the left hand side and this term to the right hand side. Let us see what happens. This becomes what? CBT2 plus P external upon P2, correct, into RT2, okay, is equal to P external RT1 upon P1. Okay, now move this term over there. This becomes what? Plus CB into T1. Correct? Let me remove the lower part. So now what we are basically going to do is we will take T2 common here because this is what we wanted. So what we'll do, T2 will take it common. This becomes what? CB plus P external by P2 into R is equal to what? P external RT1 by P1 plus CB into T1. Correct? So this gives us the expression of T2 over here. Okay. So this becomes what? P external RT1 upon P1 plus CB into T1 upon CB plus this term P external upon P2 into R. Okay, let me remove the equations from above, but before that you can just pause it and note this down. Okay, now let me remove the above equations. Okay, let me rewrite it in case it is not visible. So T2 is equal to what? P external RT1 by P1 plus CB into T1 upon what? CB plus P external upon P2 into R. Okay, let me remove the lower equations. Now, if we consider P external equal to P2, then what will happen? So, T2 is equal to P2 upon P1 into RT1 plus, we'll take this term, CB into T1 upon CB plus P2 upon P2 into R. Okay, so this will get cancelled and this becomes what? CB plus R. And what will be CB plus R? We know that CP minus CB is equal to R. So Cp is equal to what? R plus Cv. So this is becoming what? R plus Cv. So R plus Cv is equal to what? Cp. Okay, we have made a elaborate video on this topic. Okay, so if you want, you can just check my channel. There we have derived all the conditions of Cp minus Cv. Okay, so this becomes what? T2 is equal to P2 upon P1 R T1 plus Cv into T1 upon Cv plus R. Correct? You can just pause and note it down. Okay, now, so this becomes what? T2 is equal to P2 upon P1 R T1 plus Cv into T1 upon Cv plus R is equal to what? Cp. Since Cp minus Cv is equal to R, so Cp becomes what? R plus Cv. Correct. So this becomes what? This becomes T2 is equal to P2 upon P1 into R upon Cp into T1 plus Cv upon Cp into T1. Correct? So now we know that Cp upon Cv is equal to what? Gamma. Okay, gamma is nothing but the ratio between heat capacity at constant pressure and heat capacity at constant volume. Okay, so since Cp by Cv is equal to gamma, so Cv by Cp will become what? 1 by gamma. I hope I am clear to all of you. Okay, so this becomes what? T2 is equal to P2 upon P1, and R by Cp is what? It is nothing but 1 minus 1 by gamma. Okay, so if you don't understand how is it coming 1 minus 1 by gamma, we are going to derive it. Okay, just wait for 2 minutes. Okay, let me complete this. Okay, so R by Cp is what? 1 minus 1 by gamma, and gamma is what? Ratio of Cp and Cv, heat capacity at constant pressure and heat capacity at constant volume, and this is your what? 1 by gamma into T1. Correct? Okay, so this becomes what? If we take, we have missed T1 over here. So if we take T1 as common, this becomes what? T2 is equal to T1 into P2 upon P1 into 1 minus 1 by gamma plus what? 1 by gamma. Okay, so this is the overall equation. So, and where T2 is what? T2 is our final temperature which we wanted to find out. T1 is our initial temperature. P2 is our final pressure. P1 is our initial pressure, and P2 is also external pressure. Gamma is what? Ratio of Cp and Cv. Gamma is equal to what? Cp by Cv. Now, how does this R by Cp convert into 1 minus 1 by gamma? Okay, so let us see. 1 minus 1 by gamma will be equal to what? 1 minus 1 by Cp by Cv. Correct? So this becomes what? 1 minus Cv by Cp. Okay, Cv by Cp. And this becomes what? Cp minus Cv by Cp. Okay, and Cp minus Cv is equal to what? It is R by Cp. Correct? So that is why we have written R by Cp is equal to what? 1 minus 1 by gamma. Okay, hope I am clear to all of you. So we have basically found out the what? Expression of final temperature in case of adiabatic irreversible expansion, which is nothing but T2 is equal to T1 into P2 by P1 into 1 minus 1 by gamma plus 1 by gamma, where T2 is our final temperature, T1 is our initial temperature, P2 is our final pressure or external pressure, P1 is our initial pressure, and gamma is what? Ratio of heat capacity at constant pressure and heat capacity at constant volume. Okay, so this will be all for today. Thanks to all of you.